epsilon string, obviously there should be initial state, but that state itself represents, tell me what it represents.
Final state.
Very good. Now when there is no operator present, I mean there is no expression itself, so r is equal to, in that case it is
Null.
phi, null, I mean null, right? Phi, it is represented with phi. So no path exists, but states might exist, so it is simply shown like this. There will be a state q0 represents initial state, and there will be a state q1 represents final state, and you will be having simply path, no path from q0 to q1. Only you will be having two states shown here with no transition. Third, simply you are having one presence of one variable as part of the regular expression. So r is equal to simply a. In such case, you will be having finite automata of this type. Is it okay? Understood the scenario?
Yes.
Okay. Now next, we'll go to the next slide. Case number two. Case number two is for union operation. We have to assume that we have a regular expression for union operation. It is defined something like this: r is equal to r1 plus r2. Suppose it is defined like this: r is equal to r1 plus r2. Now for this type of regular expression where r is equal to r plus r1 plus r2, we can assume that r1 is a regular expression for which there exists a finite automata, because when regular expression is there, obviously there exists a finite automata. It is defined using letter m. Similarly, if r2 is a regular expression, there exists a finite automata defined using letter m2. Is that clear to all of you? Is this part clear? So there exists a machine m1 for r1 and m2 for r2. Okay, so we have to consider these two machines. So these finite automata are already existence or existing. So these are in existence. Okay, m1 and m2. Now what is the next thing? We have to just establish the link. I mean, we have to just perform union operation between r1 and r2. So how it is performed? It is done by r, and that r denotes, this is m. So m is equal to, m is constructed here, you can see this is my m whole. How it is constructed? Simply from m1 and m2, new state as initial state of m is added as q0, and only m will be having transitions or epsilon moves from q0 to q1, as q1 is initial state of m1, and epsilon move from q0 to q2, as q2 represents initial state of m2. So you are having simply epsilon moves like this. Okay, and then from final states. So obviously M1 might have different final state, M2 might have a different final state. But while deciding the final state of M, what we have to do, we will not be considering F1 and F2. Though earlier in M1 and M2, though these two states were for representing final states, now we are not considering them as final states. For M, while constructing M, we will be simply adding epsilon moves from all such final states to the newly added final state, say F0. And F0 will become the final state of M for regular expression R. Is the scenario clear? Is this
Yes, sir.
okay? When we'll solve examples, no, it will be more clear. Case 3. Case 3 is for concatenation operation. Now in this what? Again, it is the assumption that R is equal to R1, R2. This is the concatenation assumption. What I mean here is we have R1 exists. Say regular expression R1 exists. For R1, say there is a finite automata M1. And for R2, there exists a finite automata M2. So you can see here these two finite automata shown separately. This is M1, this is M2. When we say it is a finite automata, we will be having initial states, some of the dot 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 dot, dot transitions, some intermediate states. will be there inside this box. Only important thing what we have to understand is there should be a final state, there should be initial state, and there should be a final state. Remaining things are not shown. As the things are not shown, it does not mean there are no other states and no transitions. No, it's not like that. There are transitions, there are intermediate states, but only initial and final are shown while constructing M. While constructing M automaton for concatenation operation. So here you can see this is M1, this is M2. Now how the interconnection takes place, you will be considering the initial state of M1 as initial state of M. Final state of M will be considered as final state of, tell me.
M2.
Correct. Final state of M will be now final state of M2, and now the F1 will not be a final. That's why it is not shown here in M as double circle state. But that F1 to Q2 you will be having for joining, interconnecting the paths. This is separate, this is separate. So we should establish a link between one automata to another automata just by putting epsilon. Is it clear? Just
Yes.
by having epsilon move from this to this. Is this concatenation case clear?
Yes, sir.
Okay. Now next, last case, that is case 4 for closure. Okay, now for closure, how the case is added? What is the scenario? First of all, regular expression R will be equal to R1 star. So this represents closure property. Now here uh, we are having M1 exists for R1. So this is M1 which exists for R1. Okay, it is there with the assumption that it is present. Now only we have to construct M. We have to construct M as shown in the diagram. We have to construct by adding new initial state, and from that initial state you will be having two epsilon moves. One which is going to initial state of uh, one which is going to one epsilon move is going to initial state of
M1.
M1, and one is directly going to the newly added final state. Why? Because this is R1 star. So epsilon also part of the language. Epsilon is a part of language. To get epsilon, epsilon means initial state should be acceptance state. But instead of showing it like this, what we did, we have added a epsilon move directly from initial state. You can reach to a final state. Is it clear?
Yes, sir.
Okay. So this part also it is clear to all of you.
Yes.
Okay. So what we'll do here, we'll end our lecture. The example, okay, actually I'll give you the example. You can give a try if you are able to. Immediately take down the example. We'll see the solution in the next class. So construct, take down, construct NFA with epsilon moves for the regular expression A plus B star ABB. So you can give a try for this. We'll discuss the solution in the next class. Is it okay?
Yes, sir.
Okay, fine. Any doubt?
No, sir.
Any doubt to anyone? This Jamboard is already shared with all of you. You can refer the points again while solving this problem. If you don't have any doubt, we'll end the lecture. Thank you for attending the class. Good day. You can leave the meeting.